Alright, we're going to finish up our optimization section here with a couple more examples, and then I'll be sending out some worksheets for you to work on throughout the week, and yeah, just let me know if you have questions on those. So let's go ahead and get started here. So we have two posts, one 12-foot high, they're 28 feet high, standing 30 feet apart. So we're going to draw a picture of this. So this is basically what we're looking at. So you guys can go ahead and pause this, write down write down the problem, and then come back. So on our diagram that we have here, we first of all have our left-hand side is going to be, which you could draw it the other way if you really wanted to, doesn't really matter. But this is our 12-foot pole. This will be our 28-foot pole, and they are 30 feet apart. I'm going to draw this, write this a little bit lower. You'll see why here in a second. So they are 30 feet lower, or 30 feet apart. There's a stake here in the middle holding up their wires that are connecting the wires that are holding those poles up. So the question is, where should the stake be placed to use the least amount of wire? So basically what we're looking at here, we're going to write an equation. I'm going to use W for wire. We need an equation that's going to look at adding this side right here, let's, I don't know, label it whatever you want to, Y, and this side over here, which we'll label Z. You can use whatever letters you want to. I'm just going to stick with X, Y, Z, and W for wire. And then down here, because we're basically going to be looking at using Pythagorean theorem, because these are right triangles, assuming the poles are straight up and down, we're going to be using Pythagorean theorem. So this side over here will label something. You can either, and kind of this is going back to kind of like what we did in the taco cart, where we'll give one of them a variable, and then we'll say this one over here, if we know this is x feet, then this one over here has to be 30 minus x feet, right? Because the total distance is 30. So now we can do this. So the length of y is going to be square. So w is, let me back up here a second before I do this. W is our primary equation, and this is y plus z. But remember, we need this to have the same variable. So that's where we come into plugging something in for y, plugging something in for z. So we're going to say w is equal to y from the Pythagorean theorem is square root of 12 squared plus the bottom is x squared. And then z, we're going to add to this, z is going to be the square root of 28 squared plus the bottom, which is 30 minus x squared. Okay, so go ahead and simplify that. We can't add these like putting them together into one square root. You can do that when you're multiplying, but not when you're adding. So go ahead and simplify that and see what you get. So what I got was a 144 plus x squared. And then over here, after I simplified and added together, 28 squared gives you 784. 30 squared is 900. So add those together, you get 1684, which you could put the x squared first if you want in both of these cases. Doesn't really matter. Minus 60x plus x squared. So that's what you should get underneath this square root when you simplify. So that is our function. In order to find the minimum, or what the least amount of wire would be, we got to take the derivative of it. So again, let me, I'm going to move this over a little bit. But if you remember, whenever we do a square root, I'll make a little side note of this. Whenever we do the derivative of a square root, let's say if we have y equals 1 over the square, ooh, not 1 over, sorry. And whenever, like let's say if we have the square root of u, when we take the derivative of this, we always end up with 2 square root of u on the denominator, and then the numerator is always the derivative of the inside. So just kind of thinking about chain rule with your square root, you always end up with this kind of, you always end up with this type of fraction for your answer. So I'm just going to jump right into that. So 2 for the first one, 2 times square root. Now my u function is 144 plus x squared. And hopefully you've done enough square roots that you can see that this is what we've ended up with for our derivatives. But if not, that's just kind of a little template or whatever you want to call it. So then the derivative of the inside, the derivative of 144 is 0, plus the derivative of x squared is, I don't need a plus sign, just need a 2x. Okay, next one, plus, actually I'm going to clean this, not clean it up, just slide it over a little bit so I have, make sure I have enough room here. So again, 2 times the square root on your denominator, so 164, oh yeah, 1684, missing a number in there. 1684, there we go, that's better, minus 60x plus x, oh my word, what's going on? Plus x squared, all under the square root, and the derivative up top, the derivative of 1684 is 0, the derivative of negative 60x is just negative 60, and the derivative of x squared is 2x. So now, we need to set this equal to 0. Very, very common mistake is people will just say, well, 2x plus negative 60 plus 2x equals 0, because in order for this to be equal to 0, it's just the numerators that are 0. Which is correct, if this is all in one fraction, but it's not. We have a plus sign here. So we have a little bit more work to do. So first of all, what I'm going to do is I recognize that I have a 2 that will divide out here, and I have a 2 that will divide and make this a negative 30 plus x. Get rid of that 2 right there, okay? So now I'm going to set this equal to 0. So x over square root of 144 plus x squared plus right side negative 30 plus, not right side, other function, over 1684 minus, eventually I'll actually write what I'm trying to write, minus 60x plus x squared. Okay, we want to see where is this equal to 0. Now, when we're doing this, what we need to do is we have to basically just move one of these over. Doesn't really matter which one. So basically what I'm going to do is I'm going to move this one over and then change the, so I'm going to subtract this from both sides. Right, I'm going to move this whole thing over here. So when I subtract it, all it's going to do is change the signs up top. So it's going to be 30 minus x. So x over square root 144 plus x squared equals, and again I'm subtracting this over, so all that's going to do is just change my signs up top. This whole thing that I'm kind of getting tired of writing, should have labeled that something else. So anyway, so there we go. Now, how do we solve this? Because I don't know if this is something that you've done in Algebra 2 or not, but you've definitely done this concept before. If you have a fraction equal to a fraction, how do we solve that? And that's basically just cross multiplying. So we're going to cross multiply these. So x times square root of 1684 minus 60x plus x squared equals, I'm going to put this in parentheses now, 30 minus x times 140, wow, that should all be under a square root. See if I can squeeze that in there. 144 plus x squared, okay? There we go. All right, so now, next step, we want to be able to solve this for x. So what we will do next is we're going to take both sides. I'm going to put big brackets here. We're going to take both sides, and how do we get rid of a square root? We square it. So big brackets around here and square it. So what we end up with then is we have to square each of these. So x squared times 1684 minus 60x plus x squared equals, this side squared means we have 30 minus x quantity squared times square root of 144 minus, plus x squared. If we square that, we just end up with 144 plus x squared. So we got a lot more work to do here. This is very algebra intense problem here. It's the calculus is pretty much finished way up here. We took our derivative, set it equal to 0. That's the calculus part, but you can see we have a lot more algebra to do here. So 1684x squared minus 60x to the third plus x to the fourth equals 30 minus x. If we square that, we're going to end up with 900 minus 60x plus x squared, which should kind of look familiar because we did that right here. I just did it all in one step, combining it with that, but if you did that separately, you should already know that from right there. And then times 144 plus x squared. Okay, 1684x squared minus 60x to the third plus x to the fourth equals, this side we got to multiply this through, okay? So we're going to do 900 times 144 equals 12,9,600 plus 900 times x squared is just 900x squared. And I'm going to run out of room. Let me try and move this over, see if I can get it to stay all on one line. I may need to spill over into a second line though. Minus 60 times 144, multiply that. 60 times 144 gives you 8640. That looks like a 9, but that is a 4. Let me try to fix it, but make it look worse. Minus 60x squared, and then multiply your x squared through, so plus 144 x squared. Oh, I think I might be able to fit it. Plus x to the fourth. There we go. All right. So here we go. Let's move it all over. Now, I recognize that, wait a second. This should be a third. I don't know if I wrote a third or not. 60x times x squared should be x to the third, because that's actually going to cancel out with the right-hand side. So I don't know if I said that or if I wrote it or what, because this is whatever. But this should be negative 60x to the third when we multiply that over there. So let's make sure you fix that one. All right, because it's going to cancel. Negative 60, gone. X to the fourth, gone, which is good because if we had to factor something with an x to the fourth, that would be a giant pain. So let's move some stuff around now. So 1684, we need to subtract 144. Okay, so once, actually, and the 900 here. So if we take 60, I'm going to do this all in one step. 900 plus 144 is 1044. So 1684, you could do them separately. You could subtract 900 and then subtract 144. Or you can add 144 and 900, like I said, to get 1044, subtract it from this. Either way, it doesn't really matter. We're going to end up with the same number of 640. So 640x squared. Okay, 640x squared. Do we have any x's? There should be some x's in here. Yeah, I missed another x right here because this whole term right here was messed up. Let me just fix the whole thing. Minus, apparently when I multiplied 60 through, I just multiplied 60 and not 60x. So 8640x. Okay. Move that over, so plus 8640x. All right. Minus 129,600 equals 0. Okay, so pause the video and factor that, okay? There is a common factor that will divide out to drop these numbers way, way down. So divide out your common factor and then unpause the video and watch me finishing it. But yeah, take this, factor this out, simplify it, and then let me know, or yeah, just factor that out, see what you get, and then unpause the video and I'll finish it up then. Okay, so hopefully you recognize that there is a common factor of 320 that we can divide out of all these. So let's divide that out. So we're going to end up with 2x squared. 8640 divided by 320 is 27x minus 129,600 divided by 320 gives you 405. All right, so now we have to factor this. And again, you can factor it however you choose. I like to use this magic X method. 2 times 405 gives you 810. And this may be one, well, I guess that'd be a negative 810. This is kind of like one of the downfalls to it, is like I had to work with this for a while until I found some that work. But eventually I got to 45 and negative 18. But again, that took me a little while to do that. Now divide by a, so I'm dividing by 2. 45 over 2 does not reduce, but this will reduce over here to negative 9 over 1. So factored, we get 2x plus 45 and x minus 9 equals 0. Okay, so if we look at this, solving this one here, the 2x minus 45, we solve that for 0, we're going to get 22.5, negative 22.5. So that one's out because we're looking for a distance, right? We're looking for this x value. So that has to be 9. X equals 9 is our answer here. But that's not our overall answer. That was just the answer to this part. We now have to come back up all the way up to the top here, and we're going to plug in 9 for x in both of these cases. Actually, let me come back up to this one and plug 9 in for x to get your final answer there. So go ahead and do that. Plug that in. I don't see that on my paper anywhere here, so let me also plug this in. So 144 minus 81, and then plus second square root. We're going to do 28 squared plus 30 minus 9 will give us 21, so I'm just going to say 21 squared. So you end up getting on this part right here, when you plug that in, what I got, if I plugged it in correctly, should be 42.937, okay, feet of wire. So you know, the stake would be 9 feet from this side, 21 feet from this side. But to answer the question, they say what is the least amount of wire, and that right here is 42.937 feet. Okay, one more question here. Go ahead, pause the video, write that down, and then come back. So what we're looking at here is 4 feet of wire is to be used to form a square. So we're going to have a square and a circle. So how much of the wire should be used for each, the square and the circle, to enclose the maximum total area? Again, there's your keywords that tells you that we are doing an optimization problem. So the maximum total area, this will be your primary equation, okay? So the primary equation is what's going to answer the question. So that's your total area, which is going to be the area of the square plus the area of the circle. I don't want to use it. I'm not going to draw a circle. I'm going to put a C for circle. Sorry. So let's say you could use any variable you want to. I'm going to use x to represent the side length of the square. So my total area is going to be, the area of the square is x squared. And then for the circle, I'm just going to stick to my pi r squared. And you can see here we have a problem because these need to be the same variable. I have an x squared and an r squared. That's not okay. So this is where we come back to our secondary equation, which is going to involve this 4 feet of wire that we know, and also what does that represent in here, which is your perimeter. So for the perimeter of this square would be 4x plus the perimeter of your circle, which is 2 pi r. And we know that that has to equal 4 because we know that's how much wire we have in order to solve this problem. We have 4 feet of wire to enclose the square in the circle. Now, one thing you want to keep in mind is that, let's say, for example, if all of the wire is being used for the square, what would the area be? Well, if this whole thing is 4, has a perimeter of 4, our area would be 1, right? Because then each side length would be 1, and 1 times 1 would be 1. We would just have like a 1 square foot square. For your radius, if all of it is used for the radius, then we would know, your perimeter would be 4 equals 2 pi r. So then the radius then would be, what if we divide that over? It'd be 2 over pi. And then to find the area, we would have to do pi r squared, so we get 4 over pi squared. So whatever that gives you, I don't know. 4 over, well, it would be 4 over pi because you would have pi r squared. So it would be 4 over pi squared, and then multiply that by pi would just give you pi. So this, you can see that if we use all of the wire for the circle, we would get a larger area than if we used all of it for your square. But we want to know how much should be used for the square and the circle. So we want to find out, there's going to be some point where we get a maximum area, which may or may not be greater than this area, but we want to know if we're using this wire for both of them, what would that be? So anyway, that's just kind of a side note there. But let me come back to this problem. So we either have to solve this equation here, our perimeter equation, for x or for r in order to solve this. So it doesn't really matter. I'm just going to solve it for r. So first of all, divide everything by 2. And then solve for r. So r is going to be equal to 2 minus 2x, all of this divided by pi. And I'm going to plug that in here now. So my total area is equal to x squared plus pi. And then if I square that, 2 minus 2x over pi quantity squared. All right, so let's just go through this and solve, simplify, whatever you want to call it, simplify this equation. So pi, if I square this, first of all, I know my whole denominator is pi squared. And then when I square the numerator, I end up with 4 minus, multiply these, 2 times 2x is 4x, and then double that, so that's minus 8x. And then square this last one, so plus 4x. Let me erase this so I can fit it all here. 4x squared. There we go. All right, now if I multiply the pi out here, it's going to get rid of one of these, get rid of this one. All right, so let's keep going here. Total area, x squared. Now, what I'm going to do, just so I'm not tempted to use the quotient rule here, is I'm going to separate these. So I'm going to say 4 over pi minus 8 over pi x plus 4 over pi x squared. Okay, so I'm just going to separate those and then now find my derivative. So the derivative of my total area function would be 2x. 4 over pi is just a constant, so that's 0. 8 over pi times x, the derivative of that would just be 8 over pi. And then plus, multiply this one right here, or not multiply, take the derivative of x squared would be 2x, multiply by that would be 8 over pi x. Okay, so now we're going to set this equal to 0. So 2x, I'm going to rearrange this a little bit. 8 over pi x minus 8 over pi equals 0. And my reason for doing that is because I need to factor out an x. But also in this step, I'm going to add this. I'm going to add this over to this side. So I'm going to do those two things here. 2 plus 8 over pi is equal to 8 over pi. Divide this whole stuff in parentheses over to get x by itself. So my numerator is the right-hand side, 8 over pi. And my right-hand side is 2 plus 8 over pi, like that. So plug that in your calculator. You will get an approximation of 0.56, and then there's a couple zeros after that, but I'm just going to fill it into 3 decimal places to get that. So that is the side length of the square. Okay, so let's come back up and see what our question says. How much of the wire should be used for the square? So this is one side length. Let me back up. One side length would have 0.560, so we're just going to multiply that by 4 to get the perimeter. So 0.560 times 4 gives you 2.2. So the perimeter, or basically how much of the wire is being used for the square, is 2.240 feet. And then if that much is being used for the square, then the remainder has to be used for the circle. If I can actually write what I'm trying to write here, that would be awesome. The circle for your perimeter or your circumference would just be 4 minus what we got right there, the 2.24, which leaves us with approximately 1.76 feet of that remainder of the wire being used for the circle. So that would be the maximum area that would use both the square and the circle. But again, if you actually look at the area for these two, it's less than the area than if we were to use the entire wire for the circle. Like that 4 over pi is whatever that area is, whatever 4 over pi, it's bigger than 1. That area is actually more than what we would get from what we have here, I believe, if we check that, if I remember correctly. So, but anyway, we wanted to know how much wire should be used if we're using both the square and the circle. So that is what your perimeters would be. That's how much wire is being used for the square and how much wire is being used for the circle. Okay, so again, there's a couple more examples on this optimization stuff. I'll send out worksheets every day this week, and like always, if you have any questions, just let me know. Either send me an email or a private comment, or you can join the Google Meets and just let me know if you have any questions.